Hello friends, I hope you are all well. Today we will discuss linear algebraic question from GATE 2021. You can see the question number 2.3. Let T, Cn to Cn be linear operator of rank n minus 2. Then 4 options are given. 0 is not an eigenvalue of T, 0 must be an eigenvalue of T, 1 can never be an eigenvalue of T, 1 must be an eigenvalue of T. So a linear operator T is given on Cn. Okay, you know the Cn is a vector space over C of dimension n, and rank of T is given n minus 2. So what will be the nullity of T? By rank nullity theorem, n minus 2, n minus rank of T, that means 2. Okay, the nullity of T is 2, that means the dimension of null space of T is 2. So dimension of null space of T equals to 2. So there is two linearly independent vectors in the null space of T. So if you take V1 and V2 linearly independent, that is the basis of null space of T, then T V1 will be 0. So you can write it 0 means 0 vector, okay, 0 into V1 vector. So T V1, we are getting T V1 equals to 0 into V1, where V1 is a non-zero vector. V1, V2, this is the basis of null space of T. So basis element cannot be zero element. Okay. So we are getting this T V1 equals to 0 into V1. So if this equation is satisfied for a non-zero vector V1, then 0 is an eigenvalue of T. Okay. So 0 always an eigenvalue of T. So 0 must be an eigenvalue of T. This is true. Now we see the other options. And we will try to discard other options by taking a particular n and particular linear operator. So choose n equals to 3 and T Cn to Cn, that means if you define Z1, Z2, Z3, that is the identity operator. If you define identity operator, you can see that okay, first of all you see 0 must be an eigenvalue of T. Okay, we are getting, so 0 is not an eigenvalue of T. This is false from the option B. So now we have to check whether 1 must be or never be an eigenvalue of T. Okay, so you can see that 1 is an eigenvalue of T, because if we take this identity operator, 1 is an eigenvalue. One is an eigenvalue of T. So 1 can never be an eigenvalue of T. This is false. And 1 must be an eigenvalue of T. You have to check this option D also. If you take T Z1, Z2, Z3 equals to 2Z1, 0, 0. Okay. Then whether 1 will be an eigenvalue of this T or not, we have to check. If 1 is an eigenvalue of this T, then there is a non-zero vector, suppose V x1, x2, x3 such that t v equals to 1 into v. Okay, to solve this, so t x1 x2, that means 2x1 0 0 equals to 1 v, that means 1 x1 x2 x3. So we are getting 2x1 equals to x1 and x2 0 x3 0. Okay, x1 is a complex number, so 2x1 equals to x1, that means x1 equals to 0 and x2 equals to 0, x3 equals to 0. So we are getting that v vector is a 0 vector, okay, in C3. So we are not getting a non-zero vector v such that t v equals to 1 v. So 1 is not an eigenvalue of t. So if you take a linear operator on C3 as this tz1 z2 z3 2z1 0 0, then 1 is not an eigenvalue of t. So 1 must be an eigenvalue of t. This is also false. So option B, that is 0 must be an eigenvalue of t. This is always true.